So thank you very much, sir. Thank you very much for honoring us by your esteemed presence.
It's a pleasure, sir. It's my pleasure.
Sir, good morning, sir.
Good morning.
Sir, என்ன ஞாபகம் இருக்குங்களா?
ரொம்ப வேகா.
Sir, shall we start the program? Pandian?
மேடம் மேட்ச் இப்போதான் சேர்மனா ஒரு 5-6 காலேஜ் விசிட் பண்ணிருக்கேன்.
இல்ல அதுக்கு சொல்லல சார், நான் சொன்னது வந்து எங்களுக்கு ஐபிஎஸ்சி செட்டப் பண்ணப்போ அந்த ஏக்யூஆர் கைடன்ஸ் பண்ண மாதிரி எனக்கு
இல்ல.
ஓ சாரி சார், ஓகே ஓகே. I got confused. Maybe I got confused with someone else. So thank you very much, sir. Thank you very much for
Good morning.
Sir, என்ன ஞாபகம் இருக்குங்களா?
ரொம்ப வேகா.
Balaji.
Sir, shall we start?
Balaji, the same guy again and again came. Balaji, are you there?
இருக்கேன் சார். So don't allow more to be.
அது என்னன்னு பாருப்பா.
Pandian?
மேடம் மேட்ச் இப்போதான் சேர்மனா ஒரு 5-6 காலேஜ் விசிட் பண்ணிருக்கேன்.
இல்ல அதுக்கு சொல்லல சார், நான் சொன்னது வந்து எங்களுக்கு ஐபிஎஸ்சி செட்டப் பண்ணப்போ அந்த ஏக்யூஆர் கைடன்ஸ் பண்ண மாதிரி எனக்கு
இல்ல.
ஓ சாரி சார், ஓகே ஓகே. I got confused. Maybe I got confused with someone else. So thank you very much, sir. Thank you very much for honoring us by your presence.
Good morning.
Sir, என்ன ஞாபகம் இருக்குங்களா?
ரொம்ப வேகா.
Balaji.
Yes sir.
Shall we start?
Balaji, the same guy again and again came.
Sir,
Balaji, are you there?
இருக்கேன் சார். என்ன request? Don't allow more to
நீங்க
be.
பையன் வந்துட்டே
பாலாஜி
இருக்காங்க.
2 டிவைஸ் ஆன் பண்ணிருக்கீங்கன்னு நினைக்கிறேன். எக்கோ ஆகுது. ஒன்னு ஆஃப் சேர்மனா ஒரு 5-6 காலேஜ் மொபைல் and also the system ரெண்டு ஆன் பண்ணிருக்கீங்க மைக்க. You can switch off one mic so that you will avoid the echo. Or nearby somebody is there with another mic which
So
gives
thank
you
you very
like
much, sir. Thank you very much for honoring us.
Okay sir, fine sir. Sir, don't allow anyone sir.
you don't allow any video as Professor Kamraj was telling. Because of some this online all kind of things will happen, so don't allow the video unless otherwise you know them.
Balaji.
Sure sir. Yes sir.
Yeah, I have asked them to come with ID,
Again and
abstract
again
number.
came.
They come with abstract number, allow them, otherwise don't allow them. Thank you. So,
Sir, don't allow anyone, sir.
Let's start the program. Yeah, let's start the program. Yeah, very good morning to one and all. Respected Chief Guest, Dr. Venkatachalapathy, Vice Chancellor, KARPAGAVINAYAGA Academy of Higher Education, for joining us as to inaugurate this program, RASTEMS 2023, the international conference organized by New Reigns, New Research and Innovation Society in association with ADDIS, ABABA, University of Science and Technology, Ethiopia, and KARPAGAVINAYAGA College of Engineering and Technology, Chengalpattu, India, and supported by Right Click Singapore. I welcome our chief guest, Dr. Venkatachalapathy, once again to this international conference. I also welcome the guest of honor, Dr. Venkatesh Babu, Pro Vice Chancellor, Bharat Institute of Higher Education and Research, India. So let me introduce for a few minutes about our guest of the day. Dr. Venkatachalapathy was earlier, he served as Dean Research in Rajalakshmi Engineering College for many years, and followed by, he also occupied the position of Dean Research in SRM University for many years. and he has got several projects. He has made a lot of wonderful achievements in his research career, and he is a well-known researcher in chemistry all over India. He is known for his research expertise, and he is currently the Vice Chancellor, Karpagam Academy of Higher Education, Coimbatore, India. I am very happy to see him as our chief guest of this international conference. I would also like to introduce shortly our Pro Vice Chancellor, Dr. Venkatesh Babu. He is a doctorate in mechanical engineering. He has served as a professor and a principal in many organizations, and he has also served as dean in Bharat Institute of Higher Education, and later on he moved to Delhi as Pro Vice Chancellor of a deemed university, and he came back to Bharat Institute of Higher Education, and he is serving as Pro Vice Chancellor International Relations, and he is taking care of a lot of initiatives related to international relations. He has got a lot of significant MOUs with various international universities. I am happy to see him as our guest of honor. Thank you, sir. Thank you very much. I also welcome the convener of this conference, Dr. Bala Muralidharan, Professor of Mathematics, and I welcome the Dr. Jagannathan, Professor from SRM University, Dr. Pandian from University of Madras, and various faculty members, heads of the departments, and the deans, Dr. Nedinjalian, Dean of Computer Science from Baigar, and I welcome you all. I welcome the students and research scholars and all the delegates, and also one of our students, Mr. Balaji, who is supporting us in all our online activities. I welcome one and all to this program. Shall I invite the Vice Chancellor, Dr. Venkatachalapathy, to inaugurate this conference? Please, sir.
Thank you. My dear friend and the conference convener, Dr. P. Kamaraj, Dean, Bharat Institute of Higher Education and Research. Today's guest of honor, Dr. R. Venkatesh Babu, Pro Vice Chancellor, Bharat Institute of Higher Education and Research. Dr. Girma, Director, Research, ADDIS, ABABA, Science and Technology University, Ethiopia. Professor K. Pandian, Head, Department of Inorganic Chemistry, University of Madras. Dr. Kasinanda Pandian, Principal, KARPAGAVINAYAGA College of Engineering and Technology. The conference convener, Bala Muralidharan, and keynote speakers, session chairs, co-chairs, invited speakers, participants, researchers, and students. I wish you all a very happy morning. I am honored and delighted to be here to inaugurate the International Conference on Recent Advances in Science and Technology, Engineering, Management, and Social Science 2023, organized by New Research and Innovation Society, Chennai, ADDIS, ABABA, Science and Technology University, Ethiopia, in collaboration with KARPAGAVINAYAGA College of Engineering and Technology, Chengalpattu, India. I am very happy to see the presence of many eminent speakers from various institutions across India and other countries. The deliberation as well as the recommendation of this international conference will carry greater weight and reach the appropriate audience. I would like to compliment the organizers of this conference for their initiative and efforts to make this event a memorable one. Conference like this will provide a valuable opportunities for young researchers, faculties, industry, and decision makers. I am sure you will have a fruitful and rewarding exchange of thoughts in the next 3 days. I am very delighted to note 300 papers are going to be presented for the next 3 years, in addition to many keynote and invited lectures. Coming to the international conference, I'm very happy to note this is a conference which has multidisciplinary approach. Normally, what happens is when we have such conferences, they will have many, they will have many opportunities to deliberate and take it as a message. Basically, my experience is from industry. I had 10 years of industrial experience, and my main domain is on pharma industry, where I have done many process development, new drug discovery, and many other aspects, which gives me a lot of confidence in academic. My message would be, normally what happens when we do a research, we take up some objectives and then try to find the end application. Maybe when we fix the end application and then fix the objective, definitely you will be achieving some what you call a new process or a new product or a new concept. Normally, many researchers have been ends up only in publication. Maybe if you have a very good target or the end application, if you can foresight in the beginning, definitely your research will be the most rewarded and the most wanted one in your domain. Whatever may be your domain, you can take that, you can identify some of the applications, or it can be related to maybe for management and social science, it may be related to the societal application or anything. If it can reach the society, then you will be, that kind of research will always be remembered, and your name will be always there. So there are many initiatives happening, many problems are there. Try to identify the solutions for the problem. Maybe we are going to face a very big issue of water scarcity in future. Only way to get rid of it is we have to make or invent some new methodologies to purify the water that is being let out and recycle it, and we can make that water for other application, so that we will not face the water scarcity or the drought which many countries are facing now. The recycling of water, I'm taking it one as an example. It has many potentials. As you are aware, in many countries, the sewage water is being treated. It is even being taken up to the drinking purpose with many technology interventions. So always try to focus on some societal application in your research, so that the people will get benefited and your research will also gain what you can file it as a patent, and many revenue generation is possible today. Waste to wealth is the new concept which is emerging around the globe. Whatever waste is there, if we can convert it into any form, maybe energy, very highly coming up now, the technology is biohydrogen or green hydrogen. From the waste, if we can, there are technologies available. If we can invent new cost-effective technologies, but biohydrogen or green hydrogen from the waste that is going to be the most rewarding research, and that technology can be sold and it will be definitely useful for many people around the globe. Thank you very much for the opportunity. I wish you a very success to and import of this conference, and look forward to hear about the outcome of the conference. Thank you very much for the opportunity given. I once again thank the conference organizer, specifically Professor Kamaraj, for giving me this opportunity. I wish all a very happy, fruitful, and enjoyable day. Thank you very much.
Thank you, sir. Very nice speech, sir. Thank you so much, sir.
Thank you. Your mic is on mute, Professor Kamaraj, sir.
Yeah. Thank you, sir. Thank you for the enlightening talk, for all your wishes. I now invite Professor Venkatesh Babu. Pro Vice Chancellor, Bharat Institute of Higher Education and Research, to deliver his talk. Welcome,
Thank
sir.
you very much, sir. A very good morning to one and all present over here. The chief guest of the day, Professor Venkatachalapati, sir, Honorable Vice Chancellor from KARPAGAVINAYAGA Academy of Higher Education, the convener of the conference, our Dr. Kamaraj, sir, and my very good friend, Dr. Kashinatha Pandian. I think he has not joined the meeting, or is he there, sir? Dr. Kashinatha Pandian. So, we've been friends for almost 15-20 years. So, as Professor was remarking, it is conferences like these that give a wide platform for all the researchers to get to know their peers, to get to know what is happening in their field of research. And this networking will help all of them to use the potential resources, know what are the various latest advancements that are happening in their fields of interest. And as I was remarking, it is conferences and opportunities like these that give us a chance to meet our colleagues and other friends and peers. Having said that, so this is a very nice time for this conference being inaugurated by Professor Venkatachalapati, who is a professor from chemistry, and our Dr. Kamaraj is also from chemistry. And coincidentally, yesterday only the Nobel Prize for Chemistry has been announced. So it's quite a remarkable day for the conference to start on such a very good note. So having said that, I sincerely hope that these conferences in which these papers are published, the research findings, as most of us would have noted, the main focus of the research for the young researchers nowadays should be to get beyond papers and patents. Because papers and patents, we often see that the research, the purpose of the research is mostly towards getting their PhD satisfied. So whether it be the norms, number of publications to be made or the number of patents to be made, once that is achieved, we find that there is a lacuna in the research enthusiasm of the researchers. So that should be stopped. And as the popular saying goes, the research should be aimed at from the mind to the market. How you can commercialize, how you can put your invention or put your finding, put your discovery into proper use. So when we say commercialization, we don't mean it only in a business sense. If you can put it in a socially usable, socially viable environment, then that's what gives the actual satisfaction, and that's what shows the actual success of the research. So having said that, I sincerely hope that many of the findings which are going to be presented in this conference would move towards in that direction. And I wish that all the researchers and scholars present here will make use of this wonderful opportunity. And I congratulate the conveners, the New Reigns, the Addis Ababa Institute of Technology, Karpagavinayaga Engineering College. So all of them, all the very best in making this conference a grand success. Thank you very much, all of you. All the very best. Thank you.
Thank you so much, sir. Welcome to our new right.
Thank you, sir, for your enlightening words and encouraging talk. Thank you very much for gracing this occasion. I thank the chief guest, Dr. Venkatachalapathy, Vice Chancellor, Karpagam Academy of Higher Education, and Professor Venkatesh Babu, Pro Vice Chancellor, International Relations, Bharat Institute of Higher Education and Research. I thank both of them for visiting over here, for addressing our conference delegates, and have given a very good research, guidance, and support. Thank you, sir. Thank you very much. Thank you.
Thank you, sir. Thanks.
I thank all the participants, professors, heads of the departments, and all the delegates who are going to present their papers by during oral presentations, as well as by poster presentation. I wish them all the best. I hope you'll be able to use this occasion for presenting your research, also to share your research to others, and you also learn others from others what they do, what research is going on in and around us. So I think these 3-day deliberations will help all of you, as our Pro Vice Chancellor has rightly said, and our Chief Guest Vice Chancellor said, let us make waste into generation of energy and other useful products. Let us move our research towards positive things. Let us use the latest technology in that way. So I wish you all the best. Thank you all. Thank you very much. Dr. Balamuralidharan.
Oh, yes, sir. Yes, sir.
Yeah. You want to speak a few words?
No, nothing, sir. Sir, Viswanathan, sir, just now joined, sir.
Dr. K.K. Viswanathan.
Yes, sir.
Yeah. Professor K.K. Viswanathan from Samarkand University, Uzbekistan. Sir, welcome you, sir. Welcome, Professor. Welcome.
Welcome. Thank you, sir. Thank you so much.
Please speak a few words. You are welcome to talk a few words before our audience and our delegates. Professor K.K. Viswanathan is Professor of Mathematics. He is now serving as Professor in the Department of Applied Mathematics in Samarkand University, Uzbekistan. I welcome him to deliver his speech. Please, sir.
So, should I deliver speech now? Presentation? Not presentation.
Yes, sir. Yes, sir. Yes, sir. You can start.
You can please talk.
Yes, sir. Yes, sir.
Okay. Because
take on this session.
Time schedule is 11 o'clock.
Okay, that I know. You can speak a few words.
Oh, few words. Okay. Sir, the echo is coming, sir. Echo coming. Why? Okay. The echo is coming.
Okay.
Echo coming.
Okay, sir. But we hear you clearly.
Okay. It's okay, sir. No problem. Okay, thank you, sir. Good morning to all. So I thanks to all the delegates and our professors, all of them, to invite me to participate in the conference, the RASTEMS 2023. So particularly I thank Professor P. Kamaraj, Dean of Bharat Institute of Higher Education and Research Institute, and all other professors, Professor Venkatachalapathy, Pro Vice Chancellor, and Venkatesh Babu, Pro Vice Chancellor, and Grima Gonfa from Ethiopia, and Kasinda Pandian, Principal, KARPAGAVINAYAGA College of Engineering and Technology, and Dr. K.P. Pandian, Head Inorganic Chemistry, University of Madras. So I thanks to all professors and to arrange the conference and the participants. So I am from Samarkand State University working as a professor. So this conference gives a maybe the good impression to the scholars, research, particularly the research scholars and the young researchers to know the new ideas from our different field like mathematics, chemistry, physics, and all other engineering subjects. And particularly that I am from mathematics department. So, so most of the students in our Indian, that is in Indian professors and other faculty members think the mathematics is only for teaching and it is not much we are using in the different areas, but it is in the, you come to the some other universities in abroad. This is the mathematics is a particular interdisciplinary subject. We have to use in all engineering fields, particularly the differential equations, how to solve the differential equations using the numerical techniques and many approximations. So, so these are the things we have to advise to the young researchers how the mathematics are used in widely in all the areas. So, and one more thing, particularly that our particularly the engineering colleges, they think the engineering, the mathematics is the only subject for teaching. They cannot do anything in research, much research in the mathematics subject. That is some bad impression comes in our countries. But you come to the US, UK, or Korea. So I worked in Korea. In 2003 to 2010. So I was working in mechanical department. So my research area is in applied mechanics. Completely they used me how to solve the problems in mechanical problems, everything. Even I worked in the naval architecture and ocean engineering and the Department of Mechanical Engineering. So we have applied our methods and everything. So to solve easily in the mechanical problems, everything. So and also we have taught that some that engineering subjects, mechanical subjects also I taught to the engineering students because we are strong in mathematics, so we can teach the engineering that mechanical subjects. Some mechanical subjects very mathematically very strong. We can give the foundation. Mathematical knowledge to the students, and so this is my opinion. I advise to our because there are vice chancellor is there, some principal, everybody is there. So my advice is so you are thinking that mathematics is only for mathematics department. Just we have to leave that idea. So you should use them in the mechanical department, civil engineering department, even computer science department. Everywhere you have to use them. So the particularly the young mathematicians, they are coming, so you should give the some opportunities to the mathematics people, mathematics lecturers to engage the other department subjects also. So they also get the ideas, some knowledge in other areas, some mechanical, civil, or computer science. So they can develop their research, everything, research ideas, everything they can develop, and so it will be very good for particularly the mathematics people. So this is my advice. Okay. So this is my suggestion to how to use the mathematicians in other field. Okay, sir. So many thanks to all of you. So to invite me to give the presentation. So I wish the conference will be success for 2 days, 2 and 3 days, and I wish all the participants to make the success this conferences. Thank you, sir. Thank you so much.
A wonderful suggestion, Professor Vishwanath sir. It is a wonderful suggestion. Mathematics, they are not finding the importance of mathematics. Mathematics is applied. You are telling about the mechanical engineering. Not only in mechanical engineering, all engineering mathematics is the fundamentals. where actually the problem prevails is mathematics teachers are not telling where it will be applied when they teach mathematics. Whereas the core subject teachers do not know mathematics at all. We have to bridge the gap. If we bridge, definitely without mathematics, you take any technology, whether AI, ML, data science, whatever new technology, the fundamental, unless otherwise they have a strong mathematics, they cannot become good or they cannot excel in the profession. It's a very good idea. Let us work together to make mathematics an application oriented towards engineering, which I am insisting in every meeting. Thank you very much for bringing the importance. Thank you very much.
Thank you. Thank you so much.
Thank you, Professor Viswanathan, for your thought-provoking talk, and it is really significant. And all of us agree that, as our chief guest said, mathematics is very, very important. Without mathematics, the world cannot move. That we understand. So I once again thank the chief guest, Dr. Venkatachalapathy, Vice Chancellor, Karpagam Academy of Higher Education, Professor Venkatesh Babu, Pro Vice Chancellor, Bharat Institute of Higher Education and Research, Professor Viswanathan, Professor of Mathematics in Samarkand University, Uzbekistan, and all the delegates and the heads of departments. Dr. Nadijalian, are you in line?
Yes, sir.
Yeah.
Yes, sir.
Do you want to speak a few words?
Anyway, tomorrow is our session, sir. Today I'll explain clearly about.
Anyway, thank you. I thank Dr. Nadijalian for joining us, our Dean, School of Computing, Bharat Institute of Higher Education and Research, and everyone. I thank everyone once again for this support. And we have received more than 300 papers, and most of the papers are going to be presented in our conference. I want all the delegates to make use of this conference, and as we have already informed, most of the papers, full papers received, we have received almost 80% of the full papers, which are going to be published in Scopus index journals. I thank one and all once again. Let us again, as we already informed you, this is track 1. All the delegates who are supposed to deliver talk in track 1, please remain here. Others, please leave and join track 2 for your oral sessions. Thank you all. Thank you very much. Thank you, sir. Thank you.
Thank you, Professor Kamraj.
Thank you, Professor. Thank you.
Take a
Thank you. Thank you, Professor.
Thank you for the opportunity.
Thank you. Thank you, sir. Thank you. Thank you, Professor Viswanathan.
Thank you, sir. Thank you. Thank you so much.
Thank you, sir. Thanks, sir.
Okay. Thank you. Thank you.
Sir, better, sir, we start the session, sir, better.
Yeah. I now, oral session only, no?
Sir,
invited talk.
Yes,
Yeah,
invited talk, Viswanathan, sir.
I welcome Dr. Ramesh Gaddas, Professor of Chemistry, IIT Madras. Good morning, sir, and welcome, sir.
Good morning. Thank you.
Good morning. So, we are now going to have the invited talk to be delivered by Dr. Ramesh Gaddas. He is Professor of Chemistry from IIT Madras. He has published more than 300 papers in Scopus Index journals. He has got patents. His specialization is in ionic liquids, and he is an editor of many international journals, and he has delivered invited talk in over 300 programs. I am very happy to have Professor Ramesh Gaddas here as the first keynote speaker of the International Conference on Recent Advances in Science, Technology, Engineering, RASTEMS 2023. Welcome, sir. Now the mic is over to you.
Yeah, thank you, respected Professor P. Kamraj, for a nice introduction. And For me, already stage is set as a chief guest of this conference and the guest of honor of this conference. Both of them spoke the need of the hour, the sustainable solutions and converting waste into wealth. And the first keynote talk is also on the same topic. And I'm very much delighted that our entire delegates and the audience have already heard about the need of this. So let me begin my talk thanking all the organizers from the New Reigns and ASTU and KARPAGAVINAYAGA College, so all of them. So I have put there all these people's acknowledgements. And today's my keynote talk will be on benign solvents. So let me begin. Please note down my email ID. You are welcome to ask me question at the end of this talk if time permits. Otherwise, you can write to me, gardas@iitm.ac.in. So let me begin thanking all my students, collaborators, my mentors, and my previous and current institutes where I worked, and funding agencies, and last but not the least, the today's conference organizers. I would like to begin with this logo. Many of you might have seen this earlier. This is United Nations Sustainable Development Goals logo. With short, we call UNSDG logo. It has 17 colors and each one of them represents one goal. As a chemist in a particular, but as a scientist and an engineer, we all have to contribute, at least if not all of them, at least one of them, if not directly, at least by indirectly. So we'll proceed. I'm not going to read what are these goals, but in short, if somebody asks what is sustainable development, a thumb rule says whatever the natural resources we are enjoying today and our development will not hinder this kind of enjoyment for our great grandchildrens, and we still develop. That's called sustainable development. In a scientific way, any development to be called as a sustainable development when it is economically viable. That means the industry or the organizations which is developing should get profit. Environmentally acceptable, that means it should follow all the regulations and policies of the governments and should not damage the environment. And socially equitable. The product should be affordable to almost all class of people, starting from middle class to the lower class. So this kind of developments is the need of the hour. If you see the global chemical industry, it's exceeded $5 trillion about 5 years ago, and it is expected in the next 1 decade to be doubled. So you can imagine how many chemicals are going to be synthesized, utilized, and dumped. So, as a chemist, or as a scientist, or as an engineer, we have a great responsibility and a great role we have to play, especially making use of less and less number of chemicals, or consume less, or consume natural resources less, if not completely not using. Then generate less waste. First thing is consume less. Second thing is generate less waste or less toxic material. And the last but not the least, even the whatever minimum waste we have generated, how we can convert that into wealth again. So those were the days were gone, were called a linear economy. We don't know The chemical supply chain would not aware of product supply chain, would not aware about product life cycle, or would not aware of global value chain. We don't know. The consumer is not aware from where it is coming and where it will go. We use so many mobiles. And nowadays smartphones life is maybe 2-3 years. More than 3 years using same phone is very, very rare. So where all the smartphone materials are coming, where it has been assembled, and what will happen to this phone when I give back or when I throw. I may be keeping in my cupboard or in my drawer for some time, and after several years, we don't know what to do. If any buyback policy is there, we will reuse. But the future is all about circular economy. No government is giving any approval for any of the industry, whether it is a small, medium, micro, or macro, or mega. The government asks the company before approval, show me the entire circularity, starting from raw material to production stage, to consumption, to waste management, and to recycling and closing the loop. Many mega chemical and product manufacture companies such as Dow, BASF, DuPont, Procter & Gamble, and so on, they all are started looking to reduce their environmental footprints, carbon footprints. Not only that, they have to publicize their efforts to make the sustainable process, and annual sustainability report should be available on their company websites. The nature works more or less on Newton's third law. You care for nature, or we care for nature, then only nature will care for us. If not, nature will also show its power. So there are so many do's and don'ts as responsible citizens, if not as a scientist and engineers, what we should do, what we should not do. Starting from our home itself. We are making so many varieties of pollutions. So one great man all said that the world has enough resources for our need, but will be never enough for our greed. It's not about how much we can afford. It's only about how much we need, and that many only resources. We make varieties of the pollution. Start from our home, let's say the kitchen waste and the other waste generated in home. If we do not segregate at home level, how much challenge is this? The cleaning people will say. Early morning, when the garbage collector comes to our street, there is a whistle, okay? And the boy says to mother, "Mummy, kachre wala aaya hai." Means, mom, the garbage guy came. But you see how mother responds to the boy. बेटा, वो कचरे वाला नहीं है, वो सफाई वाला है. कचरा हम कर रहे हैं. Means, my son, he is not the garbage guy. He is the cleaning person. Garbage we are doing. And he is collecting our garbage. So he is a cleaning person, not the garbage person. So our way of thinking should also change. Our action should change. If we can do at our kitchen itself, the bio waste or the kitchen vegetable or fruit waste segregate with the other waste, which we call dry waste and wet waste. Or let's say some glass item broke in our home, how we weigh. Or baby nappies, how we throw. Or the glass waste, how we throw. Or batteries in our mobile, or batteries in our TV remote, or the clock, how we throw. All this matters because we never thought what will happen to this garbage when it collected by that guy. it will go to some dump yard. From there, where it will go? It will go to some other big dump yard where it will. So what will happen? How this? The segregation itself is a very challenging. Most of the garbage go to just scintillation. They heat it at very high temperature and vaporize it. That's it. And the ash will go either for making brick or just throw as ash for some other purpose. But when we heat it at high temperature, so much air pollution, and this is again a problem. If you don't want to heat, there are many places they use this for land filling and all these things. But this is only possible when segregation has been done. So we should be careful how we are throwing our waste. It can be a paper waste, organic waste, metal waste, plastic waste, glass waste, e-waste, or the mixed waste. So it's better to segregate so the dumping guy or what you call the cleaning people can have easy life. Many of you must have watched this movie and might have enjoyed and appreciated RRR. We should also follow RRR. Here, triple R means reduce, reuse, and recycle. Reduce our needs, reuse as much as possible, and recycle at the end. One of the best RRR principle is in our house. If you have noticed, where the house has 2 or 3 kids, the elder boy's shirt becoming smaller, or the boy is growing, a shirt cannot become small, boy is growing, mother will not throw that shirt. That shirt, she will give it to the next son. And again, the other boy is growing, probably she may give it to third son if it is there. Otherwise, she will make it a what you call bag, as a vegetable bag or something. Even that bag's life goes after several months. She will not throw. She may use as a kitchen cleaning towel. Even after kitchen cleaning towel, it's very rare that we see them throw. They may use somewhere where we need it like a hide, or we need it like this one or something. So how we use our resources, our tradition and our heritage and our great grandmothers and fathers are already told. This is not about whether we can afford a new shirt, whether we can afford new kitchen towel or not. It is about lifestyle, how we consume less and reuse the product as many times as possible and recycle. Many people, I understand nowadays, they use the kitchen waste of vegetable and fruit to compost, and they may use as a fertilizer, or many are trying to make them as incense sticks and so on. But let us restrict ourselves to the solvent. If you allow me to divide the entire world's research, both industry and academia, into 3 categories: solid state research, gas phase research, and the solution phase or the liquid phase research. I have no doubt solution phase research gain a lot of interest. Probably gas phase need to handle high pressure and leakage problem. Solid state research need to be at very high temperature, so the energy is more required. And the solution phase might have various advantages wherever uniform mixing, pumping, stirring, transporting is required. Life is easy. Having said so many advantages of this solution phase research, but due to their large volatility, they do create a lot of problems. If you see, the demand for this solvent is increasing in this last couple of decades, or especially in the last decade, due to boom in the automotive, energy, and the construction sector. You see here today, the compound annual growth rate is more than 4%. And it is $50 billion market. But due to stringent environmental regulations, the companies have been forced to look for better alternatives. So they go close to the nature. Nature's solutions, problems are very close to nature. They are looking for bio-based alcohols, solvent-less reactions, or critical, supercritical fluids, or biosolvents, or nowadays where people are using ionic liquids and deep eutectic solvents. We must use green chemistry principles in our synthetic and process and product design process. The simple definition of the green chemistry says, design, the development, and implementation of chemical process and products should be such a way that should eliminate, if not eliminate, at least reduce both use as well as generation of hazardous material. So in short, before starting the reaction, during the course of the reaction, and at the end of the reaction, none of the substance should be hazardous or environmentally dangerous or environmentally not acceptable. Such a chemical should not be there. So among the 12 green chemistry principles, we will now focus on fifth one, benign solvents. Why we should look for benign solvents? What are these ionic liquids? What we are doing with this ionic liquid at IIT Madras in last 13-14 years? And what will be the take-home message? We at IIT Madras do tune the structure of this novel solvent. It's a new solvent. Why we are making new solvents? We want to replace the organic solvents. What we will do why we need to tune the structure? Because we want to have targeted properties. And why we need this targeted property? Because we need to achieve desirable applications. So this is the tagline of our research group, tuning the structure of the novel solvent for targeted property to achieve desired application. And these new solvents are ionic liquids, deep eutectic solvents, and their mixtures with water or other organic solvent. And once we make, design and synthesize and purify and study their property of these solvents, we study their thorough thermodynamic profile, we study their phase equilibria, solid liquid, liquid liquid, vapor liquid. We use this data for group contribution method and structure property analysis, and also for reverse design. Reverse designing means before designing itself, we have targeted properties, set of properties. For example, conductivity should be this much range, density should be this much range, viscosity should be this much range, heat capacity should be this much range. Can any solvent will possess this set of combinations? Then we use them for desired application, for mostly for a benign separation, extraction, enhancing the sorption, and last but not the least, waste to commodity. How we convert waste into wealth. In a mathematical form, we tried to put one equation to tell about our group, what we are doing. We integrate fundamental science and engineering approach for socially relevant and sustainable technological development. So it is a highly collaborative affair. Nowadays, whatever the expert in one field cannot convert the research from lab to market. We need to take all different kinds of people. And that's why the conferences like here, where scientists, engineer, management, policymakers, all are required at the same platform. Solvents play a key role, but it also comes with many problems due to their volatility. And these problems are many. For example, air pollution, global warming, ozone depletion, climate change, health related issue and so on. So we must minimize them or use less toxic, or we should look for renewable. This replacement should be low volatility, high stability, and the potential for multiple number of recycling. This should not lead other complication when it is used in process and product design. And last but not least, any businessman or any company would look for low cost and high yield. So when we search for such a large demanding or the large or varieties of sets of demanding for the green solvent, we also need various combinations, polarity differences, low and high, basicity differences, low and high, protic nature, aprotic nature, and so on. If you ask any student doing a research in chemistry laboratory, how you choose a solvent, he may say that whatever on the bench available or whatever cheaper, whatever easily orderable and receivable, they start. But if you ask little bit seriously involved researcher, they say, no, sir, we will look for their polarity and then temperature window range, or we look for function. But in addition to know the temperature window, that is melting point to flash point or a boiling point, the large liquid range, functional group, alcohol, amine, ester, ether, ketone, acid, many. And then polarity or polar, highly polar, non-polar. Other than this, one should also pay attention towards their chemical properties, physical properties, biological properties, regulatory classification, legal implications, environmental impact, health and safety impact. Because today we are doing some research in the laboratory scale. Why we do? If it is successful, we get an award, we get a reward, we get a degree, we get a paper, we get a patent, we get a promotion, we can get a more money. All this is fine. But if it is successful, it will go to the large scale. To go through large scale, so the laboratory scale process will go through what you call pilot scale and then industrial scale. When it goes for industrial scale, they have to check all these things. If this kind of compounds what you use, it's not available in your country, or the policy is such as that it is not usable, it is banned, then how you can do it? So at the very beginning itself, we must be aware of all these things. If you see the Kamlet-Taft plot of polarity versus basicity, these are the common industrially and academically used solvents, both polar and non-polar, and protic and aprotic. The spectrum is more or less full. But if you see for a benign solvent, more or less spectrum looks less dense. It's not full. For example, here, if you are looking for a aprotic solvent, which is benign, which has low polarity and high, this entire region is almost nil. So we cannot replace this tetra-alkyl ammonium-based solvents with the benign solvent. So we should fill this entire spectrum with large set of benign solvents. American Chemical Society Green Chemistry Institute come up with a solvent selection tool for about 272 most used solvents in industry and academia, and they developed this algorithm where we can put in a range of our targeted property, physical, chemical, biological, and also the safety score, health score, and other things. And also you can choose the functional groups of the family. And there's out of 272, using this solvent tool, you shortlist it to 5 to 10. Then you can use which is more benign, and then you can use with a specific solute. And this filter summary will help you to choose better alternatives. But it is only limited to 270. Chem21, public-private partnership company from Europe, they have published a paper, and also their website is there. Most of the chemicals used in industries, they have segregated into 6 categories, starting from highly hazardous, problematic to the recommended. with the color code. This is based on safety score, health score, environmental score. And they have divided all these solvents into various families. You can see here alcohol, ketone, ester, ether, hydrocarbon, halogenated, non-halogenated, aprotic, miscellaneous acid, amines, and so on. And they have given with the color code, problematic, hazardous to recommended. So this will help. From the same family, you can go from red to yellow to green. Of course, one should pay attention to their flash point and boiling points also. Instead of this paper, they have a website where is more interactive. So you can put in the ascending or the descending order of the score, or then you can check with the specific family, or you can check with the specific recommendation. But these are limited to 200, 250 or less than 300 solvents. But the demand is very, very high. It's not in the quantity I'm telling the varieties of the solvent. When you need 2 or 3 or 4 or 5 different sets of requirements from the solvent side, what they do, they make their binary, ternary, quaternary, and multi-component liquid mixtures. So because of this large set of requirements, the types of the solvents mixtures used is infinite. And to replace all of them, we need infinite combination of new set of solvents. And that's where it is more challenging. One such solution may arise from ionic liquid. I put here old wine in a new bottle because this is a new class of molten salts. Molten salts are known from several centuries. The only difference is these are liquid at room temperature. We all know sodium chloride will be liquid around 800 degrees Celsius, but we are talking about salts which are liquid at room temperature. Paul Walden, who accidentally discovered the first ionic liquid, ethyl ammonium nitrate, in 1914, but they told that time it's a liquid salt. This name was not coined, ionic liquids. It was called as a liquid salts. Ionic liquid name was coined by Kenneth Seddon, who is popularly known as a rock star of ionic liquids, who recently passed away. I was fortunate to work with him when I was a postdoc at Queen's University, Belfast, UK. And his student, Tom Welton, who just completed his term of Presidents of Royal Society of Chemistry, who is now faculty at Imperial College London. These two people's review paper, one in chemical review and another one in chemical society review, made this field very popular. This set of solvents possess combination of several unique properties. Vapor pressure negligible, liquid range is very high, electrochemical window is very large. This is especially for battery supercapacitor applications. Conductivity is high, solvating capacity is high, and above all, varieties of the structure possible. We call these salts as hybrid salts. So conventional salts, both cation and anion, are inorganic nature. Here, hello? Yeah, I'll close. We'll close in a few minutes, maybe 2-3 minutes. So this class of solvents are hybrid, and they possess cation and anion. And then we will have this, what you call, millions of ionic liquids possible on paper, but theoretically. And let me just tell that, having said so great about this, what is the limitation? This class of solvents have viscosity is large and the cost is high. And to achieve both the problem solution, many groups come up with using ionic liquids as a performance additive. So instead of replacing organic solvent completely from industry, if you replace completely entire process, product design, setup, you have to change, and none of the company will come forward. So instead of replacing organic solvent completely, you may use organic solvent as it is, but you add ionic liquid as a performance additive in a very, very small quantity. In this way, ionic liquid cost is not a problem. Then what is the advantage? You are not even replacing. So the idea is, for a given process and product design, without compromising on the final product's quantity and the quality, we have to reduce the organic solvent requirement significantly. So let's say for a 10 kg product, if 100 liter solvent is used, now we have to reduce this 100 liter to 50 or 30 or 20 liters by using some grams of ionic liquid without compromising on final 10 kilo product quantity and the quality. There are many applications and many books. So we were looking more as a performance additives, and we have synthesized our ionic liquids because most of the companies sell the well-known ionic liquids, and then we have studied their properties, and then we have studied their phase equilibria. We have contributed to ionic liquid database, and then we used their application with collaborations from physics, from biotechnology, from metallurgy, from mechanical engineering, from chemical engineering, and so on. So I'll just skip this application. First one was Ocean Petroleum Engineering Faculty and Oil India Limited, and where we enhanced the dissolution by reducing the organic solvent toluene requirement, and we used only ppm level of ionic liquid, and whatever toluene alone could do, by using ppm level of ionic liquid, we enhanced 67% dissolution. These are the proofs. And then oil recovery, we have enhanced by from 52 to 72, that is 20% enhancement by using ppm level of ionic liquid, and that is due to fundamental science of interfacial tension reducing between water and oil and the contact angle between rock and crude. And we have extraction capability of this radioactive material, lanthanide and actinide, we have increased threefold by using small amount of ionic liquid, and the same organic solvent, dodecane or toluene. Same thing, vapor absorbed refrigerant system. This is Indo-Spanish project from mechanical engineering point of view. So we were the first time to show that ionic liquid and water as a co-solvent can be used and to replace this lithium bromide and water. We have worked on polarity, heat transfer fluid or engine fluids, and electrolyte for dye-sensitized solar cell, desulfurization of model fuel, carbon dioxide adsorption, electrolytes in supercapacitor, ion cyanide sensing, pre-treatment of biomass, and extraction of micropollutant from water, and extraction of precious metals from e-waste. And all of them working, and the take-home message is, this is for youngsters. In research, one can find alternative for anything. If not anything, I'm sure for many things. Be positive and no negative. I tried to convince that don't replace organic solvent completely because companies may not take it, but use ionic liquid as a benign solvent, as a performance additive, so the requirement of organic solvent substantially will be decreased and no compromise on products quality and the quantity. I thank all the organizers for giving me this excellent opportunity. Thank you.
Thank you, sir. Very nice presentation, sir. So from audience, any question
Thank
from
you,
audience?
Professor. Yeah.
Audience?
Delegates may ask one or two questions.
Yes, the one question.
Sorry, I overshoot a few minutes.
Yeah, that doesn't matter, sir. Doesn't matter, sir.
Yeah. So they can write an email to me also if they don't have question now. If they have, I'm happy to answer.
Yes, sir.
I'm typing my email in.
Yeah, we will provide Professor Ramesh Gadda's mail ID that is available in our proceedings, and we will also give. You can please mail to him for any suggestions or support. Thank you very much. Thank you very much, Professor, for giving a very interesting talk in this international conference. Thank you very much. Thank you.
Thank you. Thank you.
Thank you. Thank you. Dear delegates, so now we are coming to the end of the inaugural session and end of the first invited talk. We are going to have the next talk by Professor K.K. Viswanathan, Professor Applied Mathematics from Samarkand University. Yes, Professor.
Yes, sir. Yes, sir. Entire screen.
Yes, sir. It is visible now. Yeah.
Visible, sir?
Yes, sir. Yes, sir.
Okay, okay. Yes, sir. Yes. Thank you once again, sir, for inviting me to give the present as an invited talk in the conference. Now my topic is free vibration of anti-symmetric angle ply laminated conical shells. So the presentation outlines the abstract, introduction, the problem formulations, method of spline approximation, numerical results and the discussions and the conclusions. So in the introduction, shell elements are widely used in many structures associated with the fields like shipbuilding, aviation, missiles and rocketry. So composite structures are being increasingly used because of the possible higher specific stiffness and strength and better damping and shock absorbing characteristics compared to ones made of the homogeneous materials. The use of the lamination of the structure leads to the design with the maximum reliability and minimum weight. So we are using here the first order shear deformation theory. So there are two theories, one called the classical shell theory, the other one is called the first order shear deformation theory. So the difference between these two theories are, so the classical theory is introduced by the Lau in 1888. The first order shear deformation theory is the Reisner among the first to develop the theory. The neglect shear deformation and the rotary inertia in the classical theory. In first order theory include the shear deformation and the rotary inertia. Straight lines perpendicular to the mid-surface before deformation remain straight line after deformation. So straight lines perpendicular to the mid-surface before deformation remain straight after deformation, the same thing. The transverse normal do not experience elongation. The transverse normal do not experience elongation. The normal to the mid-surface remain perpendicular to the mid-surface after deformation. Normal to the mid-surface is not certainly normal to the mid-surface after deformation. Now, we are using the laminated shell structures. So there are two types of laminations, the ply orientations. One is called the cross ply, the another is called the angle ply. In the cross ply, the ply orientation will be in the 0 degree and 90 degree. In the angle ply, the orientation will be either plus theta or minus theta, and theta lies between 0 and 90 degree. The cross ply lamination will be in this form. The layers will be formed here like this, 90, 0, 0, 90. So in this form, it may be the symmetric or anti-symmetric. Here in the angle ply, we can see that symmetric angle ply. So the 30 degree minus 30 degree, that is, suppose you are taking the 4 layer. So it will be in terms of like this. The anti-symmetric angle ply is minus 45 plus 45 minus 45 plus 45. So are the materials, but here whether it is a cross ply and symmetric and anti-symmetric angle ply, but the material should be in the symmetric form. We have to use the material in the symmetric form. So now my work is on this free vibration of antisymmetric angle ply, composite laminated conical shell is studied including shear deformation using spline approximation. The equilibrium equations are formulated in terms of the displacement and the rotational functions. These functions are approximated using Bickley type splines to obtain the generalized eigenvalue problem with suitable boundary conditions. Parametric studies are made to analyze the effect of circumferential node number, length ratio, and cone angle on the frequency parameters for different number of layers and materials with a different ply orientation under two types of boundary conditions. See, consider here the composite laminated truncated conical shell. This is a truncated shell with an arbitrary number of layers. So this is the number of layers, Z0. So we are taking the coordinate, the Z0, Z1, Z2. So Zk minus 1, Zk. So, which are perfectly bonded together. They are perfectly bonded together, all the layers. So from the figure 1, RA and RB are the radii of the cone at its small and large ends. Alpha is the semi-vertical angle, and lambda is the length of the cone along this generator, not lambda. That is L. This is the L. The orthogonal coordinate system x theta z is fixed at its reference surface, which is taken to be at the mid surface. The radius of the cone at any point along its length is RA equal to x sine alpha. So the radius at the small end is the RA equal to A sine alpha. At the other end is RB equal to B sine alpha. So the equations of equilibrium for truncated conical shells are formulated. This is the equations of equilibrium. There are 1, 2, 3, 4, 5 equations we have formed. And then we take this strain displacement relations for truncated conical shells. So we are taking this one, stress strain displacement relations. And then, I use the other slides. So the equation of stress resultant and the moment resultants are obtained by using the stress strain and the strain displacement relations are as follows. So we are taking this one, that nx, n theta, nx theta, mx, these are all moment resultant, m theta, mx theta in terms of this one. So what are the aij, bij, dij that we have to see, and q theta, qx is a transverse shears, k, a44, a45, a45, a55, these relations are there, in which aij, bij, dij are the laminated stiffness defined by aij is this one, and bij is this one, dij is this one. And k is a shear correction factor. Zk minus 1, Zk are boundaries of the kth layer. The value of the shear correction factor can be chosen according to the lamination scheme. So there are some researchers, Whitney in 1973 and Ferrara and so in 2000 have developed the procedure for finding the values of shear correction factors. And then we have to substitute into the equations. So we will get in terms of this matrix form. We can write this one in the matrix form. So, and then, we are using the displacement and the shear rotations are assumed in the separable form. So u, v, w, psi x, psi theta. So this is in the separable form we are taking. The parameters are non-dimensionalized. This u, v, w, psi x, psi y, we substitute into that equation. Under that we non-dimensionalize the equations. X equal to x minus a by L, lambda equal to omega L is a frequency parameter. gamma equal to h by RA, ratio of thickness to the ratio radius. Gamma dash is a ratio of thickness to the length. Beta equal to A by B, the length ratio. Then we substituting into that equation. So we get this one after applying the strain displacement into the equation of motion, then non-dimensionalized the parameter, thus the coupled differential equations can be written in matrix form. So it comes like this. This is the coupled differential equation in terms of x. The theta and t will be eliminated because we assumed in the separable form. It is eliminated now in terms of x. It is in terms of x. So this is the equations that operators we get L11, L12, L13, L14, L15, L21, L22, L23, L24, L25. So all the LIs are defined here, and all S1, S2, S3, those are also defined. So now this is the coupled differential equations in terms of x only. Now we have to approximate the function u, v, w, psi x and psi y, that is psi theta. So the displacements u, v, w and the rotational functions psi x and psi theta are approximated by using cubic spline functions. So because this is the second order differential equation, everything comes into the second order. So we are using the cubic splines. So the cubic spline approximation, we assume that u equal to this one, v equal to this one, w psi x psi theta. So here a i's, b j's, c i's, c j's, e i's, f j's, these are all the coefficients here. This we have to find out. This A, this we have to find out all these things so we can get U. C0, C1, C2 we find out, we get V. So similar way we get U, V, W, psi x, psi theta. Now here, in this assumption here, H is the heaviside step functions, this one. With the n number of intervals. With between 0 and 1. We made the interval is the 0 and 1 because here we made the 0 and 1. So this x belongs to 0 and 1. The collocation points are chosen. So we have to first we have to find out A0, A1, A2. How to find out? See that we choose the collocation points in interval. We choose the collocation points. 0 to 1 we take. We have to, that approximation will satisfy the points, n points. Suppose we are taking like this. The chosen from x equal to xs equal to s by n, where s equal to 0 to n. And the spline procedure produce 5n plus 15 coefficients. So therefore, we substitute into everything that at s equal to 0, s equal to 1, 2, 3, n. So we get 5n, there are 5 equations. So 5n plus 15 coefficients, it will come. When you substitute, we get the 5n. There are 5n plus 15 coefficients. When you substitute the collocation points, each point it will satisfy. So we get the 5n plus 5 homogeneous equations. 5n plus 5 homogeneous equations. So we have the 5n plus 15 coefficients. We have to find out all A's, B's, C's, Dj's, all the things. So we need 10 more equations. So for 10 more equations, what we do, we apply the boundary conditions. So first we apply the clamped boundary conditions is considered to get 10 more equations and making a total of 5n plus 15 homogeneous equations. So now it became as a, now in the matrix form, it became as a generalized eigenvalue problem. This is the thing. The resulting becomes generalized eigenvalue problem. So here M and P are square matrices and Q is a column matrix, also known as eigenvector, and lambda is the eigenparameter. So we bring into the eigenvalue problem. So this is using the spline approximation into the coupled differential equations. We take first, it becomes as a coupled differential, 5 equations, and we have to solve these equations. How to solve? We consider the spline approximation. So the differential equation comes in terms of highest degree is a second order. So if it is a second order, we need to apply the cubic spline. If it is the third order or fourth order, we should apply the quintic spline. It depends upon the order of the differential equations. So now this became as a generalized eigenvalue problem. So this we can solve using any numerical technique to solving the eigenvalue problem. So these are all the boundary conditions we used here. The clamped boundary conditions. So U, V, W, psi x, psi theta, x equal to 0, x equal to. Simply supported boundary conditions. V, W, psi x, nx, mx equal to 0, at x equal to 0, x. So by applying these boundary conditions gives 10 equations on spline coefficients, combining this one, 5 and 15 equations, the same number of spline coefficients. So now we have to solve the equations. It became as a system of algebraic equations in terms of Ax equal to lambda Bx. So there are many methods to solve the eigenvalue, to find the eigenvalues and eigenvectors. Here eigenvalue is the lambda, eigenvectors are the coefficients. A0, A1, B0, B1. These coefficients are called eigenvectors. They are called eigenvectors. Then what we did, we have studied this one. We using the numerical technique, we can find out the lambdas, eigenvalues and eigenvalues. First, we have done the comparative study, how this spline approximation is valid to apply for to solve the numerical, these differential equations. So we studied the comparative study here. So you can see here, the conical angle alpha equal to 45 degree we fixed, and some other values also we fixed. So the present study is this one. Yeah, this is the Irie et al. And Lam and Hu, then is Chu et al. So this we have done this one. So this is almost nearer to these solutions. So here 4.1, this is the 4.3.4, this is the 0.42. So this is 0.54, this is 0.56, 669, 67, 68, 0.74. So maybe it depends upon these materials and that angles and the ratios. Sometimes our values will be more approximated than these other values. It depends upon this taking the materials and other parameter values. So the variation of frequency parameters are analyzed here in our problem for antisymmetric angle laminated conical shell using this. The convergence study of the frequency parameters is carried out for clamped boundary conditions to choose the number of knots n in the range of x. Now that comparison is over. Now we have to do to show our results to make different combinations. See here we used some different type of materials, Kevlar 49 epoxy, AS43501, 6 graphite epoxy, and E-glass epoxy. 3 materials I used. All the values we have taken, so I have not given here, but the values I have taken, all the values, that EX, EY, gamma, everything, Young's modulus, and Poisson ratio, everything we have taken here. And there are we analyzed for both clamped and SS boundary conditions. And the first 3 frequencies we have taken in for all the class, all the cases. See here.
Professor,
Yeah.
Professor, 2 to 3 minutes, please complete.
Yeah, we complete, sir. Now
Yes,
we complete.
thank you.
We are in the end. Now see here, we have taken alpha equal to 30 degree, beta equal to 0.25 degree, gamma equal to 0.05 degree. 2 layered plates under 2 different materials we have taken. 2 different materials. Or 2 layers means the same materials we have used. So these are all the values we get. So you can see that for variation of n, circumferential node number. So the values of fundamental frequency increases with increase of circumferential node number n under the CC conditions. So similarly here you can see the 4 materials. 1, 2, 3, 4. 4 layers. Minus 60, 60, 60, minus 60. The material you have to arrange. This is the antisymmetric. But this must be symmetric. The material should be symmetric. AG, AGE, EG, EG. So we have taken 3 different angles. 30, 45, 60. The effect of circumferential node number n on fundamental frequency parameter under CC boundary condition. So 2 layers and 4 layers. These are 2 layers and 4 layers. And here alpha equal to 60 degree. We have taken alpha equal to 60 degree. And this is also taken 45. This is the 45 degree minus 45 degree, different. This is 60 minus 60, 60 minus 60, different combinations we have taken. And you can see the beta variations, aspect ratio. So it is in terms of A by B, so we need frequency, fundamental frequencies. This omega m we have to find out. So here we have taken these 4 layered materials. 30 degree minus 30, alpha equal to 45, alpha equal to 60 degree. And 4 layered material, different angles. The values are higher for higher modes. Yes, first frequency, second frequency, third frequency. At first, the angular frequency omega m increases gradually and steady up to some value of beta and rapidly increase afterwards. This will increase when the beta increase. As expected for very short cell, beta greater than 0.6 frequencies are very high. It goes very high, frequencies goes. So also figure 4C and D results, same characters pattern. Same patterns it is giving. Yeah. So this is the other 2 layered 30 minus 30, the beta variations. So beta variations under 2 layers 30 minus 30 for n equal alpha variation. This is the alpha variations. We are giving the alpha variations. So this is another results for 2 layers and 4 layers in the simply supported boundary condition. This is for simply supported boundary condition. The previously are clamped boundary conditions. This is for simply supported boundary conditions. Yeah, conclusion. So in this study, spline function approximation is applied for antisymmetric angle plane conical shell under the shear deformation theory. 2 and 4 layered shells are considered. It can be concluded from this study that the inclusion of shear deformation theory is more significant to study the vibration of layered structures. The results presented in this paper may be useful for designers to make required conical shapes with suitable material properties. Thank you. Thank you, sir. Thank you, sir.
Thank you, Professor Viswanathan.
Oh, thank you, sir.
Yes.
It's a wonderful presentation, sir. But the
thank
time was very less.
No, it's okay, no problem. You say correctly we have finished. No problem.
One question may be asked now. Otherwise, you can send your questions to his mail ID. We will provide you. One question, you can raise your hand so that I will permit. Anybody wants to ask any?
From audience, you have any doubt?
Raise your hand.
Raise your hand. One person put a message, nice presentation, sir.
Okay.
Okay.
Thank you, sir.
Thank you,
so much.
Professor. Thank you very much.
Yeah.
Thank you for your nice presentation, and thank you for joining us, spending your time, valuable time. Thank you for your support also, sir. Thank you.
Thank you, sir.
Thanks to
Thank you,
Professor.
sir. Thank you so much. Thank you, sir. Thank you. Bye, sir.
Okay, here, dear participants, track one people keep the same track one only. This is track one, 1 to 50. Abstract number 1 to 50 be there in the same track one. Track 2 link already I posted in the message box. Please see. Track 2 means 50 to 51 to 100. Feedback one, morning session feedback also we posted in the message box. Please check it. The attendance also we consider as same for this feedback form only. Track 2 people only, please join this link already given in the message box. Please check it. Track 1 you don't go. We same link only. We used to on a two track 1 and track 2. Sir, shall I leave, sir? Shall I leave
please,
this?
please. Is the track 1 session chair is available now?
Track 1, sir. Okay, 1 minute. Yes, sir. Minirani ma'am is there. Ma'am, Minirani madam. Hello.
Hello,
Is
sir.
Dr. Minirani available?
Hello, sir. Good morning.
Yes, sir.
Yeah, welcome, madam. Welcome.
Thank you, sir. Thank you so much.
So kindly take care of this session. I hope you have received the list of abstracts from
In
Dr.
the mail?
Balamuralidharan.
Yes. Sir, we don't send, sir.
Okay.
But,
Can you send
already
her?
said the numbers
Okay,
only.
abstract numbers.
1 to
madam,
25.
So I have not received anything in the mail. I will call out the numbers in the order.
Okay, in the order of 1 to 25 in the forenoon. Okay.
Okay.
25 abstracts are to be present now. Or if time permits, the 26 also, like that we can continue. Please proceed, madam. I welcome Dr. Minirani, Professor of Mathematics from Mumbai. Now the session is handed over to Dr. Minirani.